Welcome everybody to this video. I'm happy that you're back. We are going to be starting Unit 5, which will cover machine learning in the real world. And by the real world, what I mean here is that we're going to cover how people in industry would decide whether or not they should use machine learning to solve a problem that they might have and how they would go about that. So this is going to be a 4-video series. We're going to start with this one, which is an introduction. We're going to talk about some examples of machine learning in the real world, and then start discussing how do you go about deciding where to even start. From there, we'll look at video 2, choosing an algorithm. I have this problem and I know that I can solve it with machine learning. Now, how do I actually decide what type of machine learning I should use? In video 3, we're going to talk about the design and analysis of machine learning experiments. Because oftentimes what we're going to do is we're going to narrow down our approach to a couple of different algorithms, and then we want to test them and compare them and make sure that we're choosing the right one. So we'll look at how to do that. In our 4th and final video, we're going to talk about common software for machine learning. The opportunities for programming and machine learning are broad, and you can use a lot of different languages and libraries, but we'll cover some of the main ones so that you can know where to even start with that. But for now, without further ado, let's get into Introduction to Real-World Machine Learning. What problems can be solved, and can my problem be solved? Because ultimately, that's what we want to determine. Once again, this is presented by EDU Onyx. So what problems can be solved with machine learning? We have talked about many applications, but let's just cover some more just to keep going over how it's being used in industry, because if you have a problem or a scenario that's similar to one of these, then you know that it could successfully be solved. The first area is in medical diagnosis, and this is an example of supervised learning. Machine learning in the medical field has improved patients' health with minimum costs. Use cases of machine learning are making near perfect diagnoses, recommending best medicines, predicting readmission, and identifying high-risk patients. These predictions are based on the data set of anonymized patient records and symptoms exhibited by each patient. So this is an example of supervised learning. We also have unsupervised learning being used in industry. This is for tasks such as customer segmentation and product recommendation. We saw the value of customer segmentation when we talked about marketing and how it could be used for good business strategy. A lot of companies such as Amazon or Google are using product recommendation tools to make targeted advertisements. We also have autonomous vehicles, which would be an example of reinforcement learning in industry. Uber and other companies such as Google, most of the main car manufacturing companies, Tesla as well, are looking into autonomous vehicles, and they're doing that using a lot of reinforcement learning so that ultimately someday you don't have to drive the car, it'll drive itself. Finally, we have image recognition and computer vision. These are the primary applications of neural networks and deep learning. Images are very large, so you end up having a lot of inputs, and neural networks are a good way to handle that complexity. So a lot of cool work is being done with image recognition and computer vision. Again, this would go into the autonomous vehicles who would use a lot of these processes to understand the image or the scene that they are looking at. But let's keep going and talk about some specific companies. So Facebook, of course, is one of the pioneers and leaders in machine learning simply because they have all the data. And so some of the cool things they are doing is developing what some people are calling the chatbot army. So any developer can create and submit a chatbot for inclusion in Facebook Messenger. This means that companies with a strong emphasis on customer service and retention can leverage the chatbots even if they're a tiny startup with limited engineering resources. Of course, that's not the only application of machine learning that Facebook is interested in. AI applications are being used at Facebook to filter out spam and poor quality content, and the company is also researching computer vision algorithms that can read images to visually impaired people. So that would be a very cool application of machine learning. We have Google, and the most visible developments in Google's neural network research has been the DeepMind network, the machine that dreams. It's the same network that produced these psychedelic images everybody was talking about just a while back. According to Google, the company is researching virtually all aspects of machine learning, which will lead to exciting developments in what Google calls classical algorithms, as well as other applications including natural language processing, speech translation, and search ranking and prediction systems. Finally, we have IBM and Watson actually does more than just beat the best of the best at Jeopardy! Watson has been deployed in several hospitals and medical centers in recent years where it demonstrates its aptitude for making highly accurate recommendations in the treatment of certain types of cancer. So a lot of good uses for the machine learning research that IBM is doing as well. So these are some pretty big companies though, and it's important to remember that you might not have the resources available that Facebook or Google does. In fact, I can guarantee that you do not. So when we move on to asking the question, can my problem be solved with machine learning, we have to understand that we're not going to be able to do a lot of our own research, but we can still, or our own development of new algorithms, but we can still deploy and use algorithms that have been already used today. So let's take a look at that process. To start, we're going to have to classify our problem into one of the many categories that we've covered in this course. So remember, we have supervised and unsupervised, and then reinforcement learning, which are our primary 3 classes of machine learning. So any task or aim that we have is going to fall into one of these 3. And to start, we are going to have to make that classification. So this is going to be based off what are you trying to do. Are you trying to predict? Are you trying to make an inference? As well as, probably most importantly, what type of data you have. So let's talk about that. What type of data you have, be it qualitative or quantitative, or even unlabeled versus labeled, is going to determine the type of machine learning that you could potentially use. Additionally, how much data do I have? If I have a data set of 15 images, I'm probably not going to be able to do machine learning on this particular problem. Remember, a lot of the data sets that we're looking at in machine learning end up consisting of thousands, 10,000s, and 100,000s of example cases. The more example cases and positive and negative examples that you have, the better your algorithm is going to get. So ultimately, that is a factor to consider when you're trying to determine whether or not machine learning is even feasible for your project. But let's say that you have data and it is a particular type that you think would still work, and you have a good chunk of it, so we can move on. So you're going to look at the task. If we're trying to do prediction or inference, we're going to then move on to labeled versus unlabeled, and we're going to fall into any one of these categories. So if your task is prediction or inference, you already know that you're going to be doing supervised learning or unsupervised learning. That determination is going to be dependent on whether or not you have the expected output. Do you simply have like customer transactions? They're unlabeled, then you would want to do unsupervised learning. If you have labeled data, you have a lot of positive and negative examples, and then we can move on to supervised learning, which of course is going to contain both classification, if we're looking at a qualitative output, and regression analysis, if we're looking at a quantitative output. On the unsupervised side, you have clustering, and we've talked about it a little bit, but not as much. Dimensionality reduction would be another potential use case for unlabeled data. On the flip side of this, if our task is autonomy, you're going to immediately go into the reinforcement learning category, and that's going to have its own developmental approaches in there. Deep learning is a question that gets brought up a lot just because there's so many cool things being done with deep learning. People want to know, can I use deep learning to solve my task? Well, the first thing we need to ask, is it necessary? Deep learning algorithms have a tendency to overfit data, which we've talked about, because the number of parameters becomes unnecessarily high. If we are looking to do something that probably is linear, there is no need for a deep learning algorithm. Deep learning algorithms are used primarily in imagery and computer vision type tasks simply because that is when we have such a high number of inputs and parameters that deep learning becomes feasible. And then do I have the data as well? Because again, deep learning algorithms are going to need a lot of positive and negative examples in order to train. So if you have a data set of 20 images, again, rule out deep learning immediately simply because it's not going to be possible on the data that you have. But if it is necessary and you have the data, deep learning is one of the areas that is making a lot of progress today, and so there are some really cool things that you can do with that. But in all, this is just a great place to start. We've looked at some of the examples of how machine learning is being used in industry by some of the main or bigger companies, And then we looked at the starting process of determining whether or not can my problem be solved. Does your problem fall into one of the main three categories of supervised, unsupervised, or reinforcement learning? Good. Do you have the data? Is it labeled or unlabeled? And do you have a lot of that data? If you've answered yes to all of those categories, you can move on to actually trying to pick an algorithm to solve your problem. And that's what we're going to talk about in the next video. I have a problem that I know I can solve with machine learning. Now, how do I actually pick an algorithm to do that? So keep listening. Thanks.